Alright, so I'm going to call this radical review part 2. We did the first part of this radical review yesterday, and we're doing the second part today. So the back side starting with example 9. So the problems that we did before did not have any variables in them. And all of the problems that are on the back side, 9 through 18, they all have variables. Okay? So first of all, let's look right here. Square roots. Exponents must be multiples of, what do you think? If it's a square root, what do you think the exponent must be a multiple of what? 2. Cube roots, exponents must be a multiple of, what do you think? 3. And fourth roots, exponents must be multiples of 4. Okay, so let's look at the first example. Square root of 32x to the 4th y to the 9th. What's the index? 2, right? It's a square root. If there's not anything there, it's an implied that's a 2. Is 32 a perfect square? No, but we know how to do a factor tree, right? So this part we already know how to do. Give me 2 factors of 32. 2 and 16. Factors of 16. 8 and 2. 2's prime, 2's prime. Factors of 8. 4 and 2. Factors of 4. 2 and 2. So I write all my prime factors down as a review. So I have 1, 2, 3, 4, 5 2's. So perfect square, I've got 2 2's, but look, I have 2 more 2's. So I've got 2 perfect squares. Isn't 4 times 4 times 2, 32? Okay. Well, do you know what happens when you multiply 2 perfect squares together? The result's a perfect square. So 32, the largest perfect square it has is 16. I could say 4 is a perfect square and do 4 times 8, but 8 would still have a perfect square in it. So you'd have to break that down further. All right? So 16 is your largest perfect square. So I'm going to break that down to 16 times 2. Now, is x to the 4th a perfect square? Yeah, because what times what is x to the 4th? X squared times x squared is x to the 4th. So I'm going to leave it as x to the 4th. Is y to the 9th a perfect square? It is. 9's a perfect square. But y to the 9th, what do you think its square root is? Okay, what's y to the 3rd times y to the 3rd? Is y to the 6th, correct? An exponent is different than if it's a base. It's different. So doesn't y to the 9th mean y times y times y to 9 times, right? So if you need sets of 2, do we have a perfect square in y to the 9th? Well, we do, right? We got y squared's perfect, y squared's perfect, y squared's perfect, y squared's perfect. How many sets of perfect squares do we have? 4. Okay, so think about it like this. Y to the 9th is not a perfect square. 9's a perfect square, but not as an exponent. So if I rewrote that as y to the 8th, don't I have 8 y's there? Times y. I'm writing factors just like I did for 32. Instead of 32, I wrote 16 and 2. Instead of y to the 9th, I wrote y to the 8th times y. Okay? So could I take the square root of y to the 8th? What do you think it is? Y to the 4th. I had 4 sets, okay? So, now that we have everything broken down, I know I'm going to still have a radical in my answer because not everything's a perfect square. If it's a perfect square, put the square root on the outside. What's the square root of 16? 4. All right, so we're done with that. What do we do with the 2? Stay under the radical because we can't take the square root. What's the square root of x to the 4th? X squared. So we took the square root, it goes on the outside. What's the square root of y to the 8th? Y to the 4th. Took the square root, so it goes on the outside. What do we do with this y? Just bring it down. Does 2y, does it have any perfect square factors? No. Okay, so when I have variables, instead of writing it all out like that and circling stuff, think about it like this. We know the index is 2, correct? So if I have a variable with an exponent, take the exponent, divide by the index. What's 4 divided by 2? 2. When I took the square root of x to the 4th, what was its exponent? 2. Look at y to the 8th. Its exponent is 8. Take 8, divide it by the index. So 8 divided by 2 is 4. Notice the square root of y to the 8th was y to the 4th. So that's an easy way to take the square root. You cannot do that to the base. You can't do 16 divided by 2. Does not give you the square root of 16. It's only for exponents. All right? So let's look at number 12. 56. Cubed root of 56, r to the 8th, s to the 4th. Is 56 a perfect cube? No. Okay, so let's see if it has any perfect cubes. I could use 7 times 8. 7's prime. 8 breaks down to 2 times 4. 2's prime. 4 breaks down to 2 times 2. Does 56 have a perfect cube? Yeah. 2 times 2 times 2 times 7 gives me 56. I need 3 identical factors to give me a perfect cube. So what is the perfect cube in 56? 8, right? So I'm going to replace 56 with 8 times 7. Is r to the 8th a perfect cube? Well, it's not, but it has a perfect cube factor. What do you think its perfect cube factor is? R to the what? No. R to the, what number lower than 8 would divide by 3 evenly? 6. So I could replace r to the 8th with r to the 6th times r to the what? 2. R to the 6th times r squared is r to the 8th, right? Okay. Is s to the 4th a perfect cube? Does it have any perfect cube factors? Yeah. What's the lowest number less than 4 that I could divide by 3 evenly? 3, right? So I could replace s to the 4th with s cubed times what? S. So you can see I have some perfect cubes and some not perfect cubes. So since everything's not a perfect cube, I'm going to have a radical in my answer. So I'm going to write my radical. I'm going to go through. If it's a perfect cube, I'm going to take the cubed root and put it on the outside. If it's not, I'm going to leave it in the radicand. And I'll underline them as I go so I know I took care of it. So what's the cubed root of 8? 2. So it goes on the outside. Can I take the cubed root of 7? No. So it stays in the radicand. Can I take the cubed root of r to the 6th? What is it? R squared. The exponent divided by the index gives me the root, right? What about r squared? Can I take the cubed root of that? No. So it stays in the radicand. What's the cube root of s cubed? S. So it goes on the outside. Can I take the cube root of this last little lonely s? Nope. So it stays in the radicand. Double check and make sure under the radical that there's nothing else that's not a perfect cube or that has a perfect or that has a cube root as a factor. A perfect cube factor. Does that make sense? Kinda. Kinda. Let's look at number 15. All right, so the coefficient or the inside the radicand, just 1 is my base, right? So we don't have to deal with that. Is w to the 4th a perfect 4th?
Yes.
Yeah, so I'm not going to break it down. How about v to the 17th? Is that a perfect 4th? Does it have a perfect 4th factor? 16, right? So I would replace v to the 17th with v to the 16th times what? V. Because that makes v to the 16th times v makes v to the 17th. I just wrote it in factors that have a perfect 4th root. Okay, everything's not a perfect 4th, so I know I'm still going to have a radical in my answer. What is the 4th root of w to the 4th? W, so that's taken care of. What's the 4th root of v to the 16th? V to the 4th. What about this other lonely little v? It just stays in, right? Is there anything else I can do? Nope. Look at number 14. Go backwards. Cubed root of negative 81 p squared q to the 12th. Can I take the cubed root of a negative?
Yes.
Yes, I can. Right? 81, is it a perfect cube? No. But it probably has perfect cube factor. So I know that 9 times 9 is 81. And 9 has factors of 3 and 3. Both of them do. So does 81 contain a perfect cube? Yes. My prime factors, there's actually 4 3's, but a perfect cube we only need 3, right? So that's 27 times 3. Now listen, y'all know I don't want to leave a negative under the radical. So instead of negative 81, I'm going to put the negative sign with 27 because I'm going to take the cubed root of that. So I'll do negative 27 times 3. Is p squared a perfect cube? No. Does it have any perfect cube factors? No, because p squared is just p times p. That's it. It doesn't make 3 factors, right? So we know p squared will stay under the radical and the radicand. Have a good day, sir. How about q to the 12th? Is it a perfect cube? Does it divide by 3 evenly? Yeah, so it's a perfect cube. So I can take the cubed root of that. We can see that everything's not a perfect cube, so we'll still have a radical in the answer. All right, so let's break it down. What's the cubed root of negative 27? Negative 3. What do I do with this 3? Stays in the radical. What about p squared? Stays in the radical. What about q to the 12th? Q to the 4th. The cubed root of q to the 12th is q to the 4th. So since we take the cubed root, it goes on the outside. Look at 18 real quick. What do you think the 4th root of y plus cube quantity raised to the 8th power is? Is that a perfect 4th? When something's raised to the 8th power, is it a perfect 4th? Yes. So it would be y plus 3 quantity raised to the second power, right? Take the index, divide by the, take the exponent, divide by the index. So the whole thing, y plus 3, was all being raised to the 8th power. So that's a perfect square because that was all together. So there's no radical in the answer there because everything under the radical was a perfect 4th. Okay? So tomorrow, I'll have you do the rest of these in class on your own so you don't have homework. I'm only speaking to 5th period.